Hey, this is Sergey with Hypergrowth Engineering, and today I want to talk with you about feedback loops. Every time you are doing your work, you are reinvesting in a set of skills that is only growing over time. As you're progressing in your career, you are growing your skill set and steadily improving on the core basic skills necessary to be a highly functioning and effective software engineer. Now, in this video, we're going to talk about the many levels of feedback loops that you're going to encounter as a software engineer in your day-to-day work. This goes everywhere from your local development environment all the way through to production, where your customers will interact with your product. So going all the way from working on your local machine to your development environment, to your production environment, to the long-term insights of working with your customer and finding out more about them. So let's get into it. Let's start at the broadest scale. We look at a product that we aim to deliver to our customers. Let's say for ease of use, we're deploying a web application. So how do you find out if something is going wrong? How do you find out if users don't understand what your web page is guiding them to do? Or if a feature there is broken? Or if an error is showing up where you're not expecting it to? That's where application performance monitoring comes in, where user monitoring comes in. You have tools like Datadog that will allow you to see individual user sessions and the issues that come up there, the things where they're stuck on looking, the places where they are navigating from page to page, and some tools will even give you a full, from web all the way to your server and database backend, traces of what is going on with your application as your users are interacting with them. This can be even by the user. You find out with the customer what is going wrong or what is going right. So you find out finally at the very end, when your product is deployed to production, did your code changes actually achieve the impact that you were looking for them to achieve? Did the user find that change useful? Did it modify their behavior in such a way that they are better able to accomplish their goal? Okay, well, that might be, depending on the timeline, a day to a week from the time that you actually wrote the code. Maybe even a month if you're on a corporate quarterly release cycle, which is crazy. Imagine a feedback loop where you only find out if your changes had the desired effect 3 months after you wrote them. How can you keep that in context, that one small thing that you did 3 months ago? How can you keep that in context for all that time to be able to fix a bug when it eventually comes up and is discovered by the user? So we don't want that. We want to be able to catch errors earlier. We want to be able to catch problems earlier in the process. So let's move back just another step. What's before production? You can have a staging environment or a development environment. And this is something that is internal to your team, an environment where your code is deployed and you can browse it and verify that your features work. You can run integration tests and automated regression tests on that environment. Also, you can hire QA, quality assurance engineers, to write automated scripts, or regular quality assurance folks to individually, manually test the application and find edge cases, to find error cases, things that maybe aren't the happy path that you were expecting as an engineer. The good news for this is that the feedback loop is a lot shorter than that 3 months in production or 1 month in production. This is starting to look more like a week. So you may have wrote your code and your automated tests, your regression tests in development run and they give you feedback after your code is merged to main. Oh, that's great. Then you still sort of remember what went on, and you can file a follow-up pull request to actually fix that issue that was found in development or staging. That's great. And that's one piece of it. That's the testing portion of verifying whether the code that you wrote is meeting the product expectations, whether it's doing what was intended for it to do. And that's important. That's one step before is the user getting the benefit that you expected them to get. Now, in development, you're testing, is the benefit that we said that the user is going to get, do we think that's realized? And sometimes it's not. Sometimes there's an edge case. Sometimes there's a problem that gets caught by testing in development before it hits production, where you can get feedback, find out, oh, that was an unexpected scenario. Let me fix that before our users see that. That leads to a better user experience. That also keeps the context in your head, because that error finding is a lot closer to the point where your brain's context was focused on the problem, was focused on that ticket. Very likely that ticket may still be open and you're working just on a follow-up PR. That way you don't have to context switch as much in order to fix this problem. Tying it back to that application performance monitoring that we saw in production, you can even have your APM running in development or your staging environment and have that full stack tracing all the way from the website, all the way down to your database and all the parts of your infrastructure that are necessary, that are relevant. And you can see as those regression tests are happening, are there any errors? Are there any 500 errors coming back from your backend? Are there any performance issues that you may not have found on your local? Like for large files or for large data sets, is the amount of time that it takes for the backend to respond, is that okay? Is that within your service level agreement or service level objectives? Broadly, do your endpoints meet a certain standard? Do they return within a specific amount of time? And is your service up for a significant portion of time? So we're looking at what exactly is the performance, the objective performance measurements for common use cases in the development environment before it hits production. So that way, when our customers look at this specific edge case, when they have a scenario that is quite taxing on the system, that you've already tried that out and you know, oh, yeah, like that is going to work. And that works reasonably well. It doesn't have to work perfect if that's an edge case, but it does give you confidence knowing that you tested the edge case and that's an automated thing that you don't have to think about anymore because that's covered by tests. The only time you have to come back and address that issue that you saw is if a performance issue crops up, is if an error in your performance monitoring crops up, is if you start seeing issues that are irregular, behavior on the application that is irregular compared to what you've seen before. So we're introducing now the concept of a baseline. So what does the baseline of your application look like? What does a baseline for handling requests look like? If the usage spikes suddenly and you have a spike in CPU usage and then you're not able to handle a few requests afterwards, that might be a problem. And if that didn't happen in previous testing scenarios, then you know that that is related to your recent change. Okay, so that is all awesome. You get your testing in production by your users and the performance monitoring that keeps track of it all. We zoom back into the development environment, and that gives you a faster feedback loop. And then we can start to look at your pull requests. This is stepping back one more step in the process. What happens usually before something hits development? Before you merge your branch into main, you tend to have a pull request. And you get the amazing thing about a pull request is that it is a standard tool for you to talk with your coworkers about your code. It's a formalized document saying, what is this change? How can we test it? And a checklist to go through around what are your team standards when building code. Again, offloading a lot of this thinking that usually is bound up in knowledge on the internet. Instead, here, you crystallize that knowledge into a pull request so that just doing your normal workflow automates these excellent habits of software engineering. So you might look at, did all the tests run? Did all of them pass? By the way, in a pull request, you have a set of integrations that can automatically run tests, a linter, a auto formatter, and that will run automatically. And that will automate some of this kind of basic routine testing and routine things that you don't want to get into arguments about with your coworkers every single time. You've automated high standards by including integrations into your pull requests so that your pull request can't be merged until these checks pass. So let's say that's at the very least, at the very core, that may be your unit test pass, your linter passes, and the formatting is up to your team's guidelines. Excellent. But there's more. A pull request, what I found super handy, super useful, is having a pull request environment for your app. So we have the production environment, we have the development environment, and then before the development environment, we have a pull request environment. It is an ephemeral environment that gets spun up and down as a pull request is open. So you open up a pull request and your system may spin up its own environment, maybe with a copy of dev data or with a copy of a reasonable set of data that you can work with. Maybe it's both your front end and your back end. Perhaps it's one or the other, depending on the details of your system. And then you can, right there in your pull request, you can check, did your code work? You know it worked on your machine, I'm assuming, but now you're looking at, well, what does it look like in the interwebs? What does it look like in your, for example, Vercel environment? You browse the site and you can see, oh, this behavior looks like what I expected. Or perhaps you look at the behavior and the app doesn't function like you expected it to. And that leads to the question of, wait, what happened? Sometimes it's that you forgot a file. Sometimes you can add a file to your workspace, but forget to check it into Git. Happens all the time. And if you didn't see the app build in your pull request environment, you wouldn't have caught that. Or perhaps it's a configuration issue. Maybe you added some custom configuration in your local that didn't get reflected in the pull request environment. Oh, wow. Now that, if you catch that, that's another issue that's not hitting development, another issue that's not hitting production. So you get feedback within 15 minutes, ideally 5, of submitting your code, of pushing up your branch into your source code repository to see, oh, wait, like this has an issue. Oh, wait, I can fix this. So you have that all still in context. Before you even have a chance to switch over to the next task, you're just writing up your pull request details and your test suite runs, your build runs, and you see, oh, all this passes? Great, I'm good to go. I can continue working on adding more commits to this PR, or I can work on fleshing out the description and the test plan so that my teammates can verify this as well. Well, your PR is still in draft mode. Once you've verified for yourself and you're reasonably confident about it, and we know that some days every engineer has a time when they're, oh man, I'm tired. Like I just rolled this out and it works probably. I tested the last commit. I'm sure this one works. Testing it is too much of a pain. And you say, okay, this is ready to review. And your coworker looks at it and they're like, you know, I found this thing. I don't think that was expected behavior. Did you mean for this to happen? And you can say, oh, thank you for finding that. I did not expect that to happen. Let me go and fix that. So that's another feedback loop. That's another fast iteration cycle that allows you to learn from your mistakes. So we have the pull request where, to summarize, you have your integrations, your automated integrations, and your pull request template that automate your team's best practices. And then you have a second set of eyes that would check out what your code does and whether it fulfills the product requirements, whether it fulfills the user story that you were working on. Awesome. But can we get faster? And I'd say yes. Let's go all the way back to your local development environment. Your local environment is the place where you do work and provides you with your fastest iteration cycles. These cycles are on the order of milliseconds to seconds, perhaps a minute. And that is crucial. The faster your iteration cycle, the more learning you're going to get in, and the better quality product you're going to get. Again, with the compounding returns on your learning. The more you learn and the faster you learn, you steepen your learning curve, and it doesn't feel as effortful because the information that you need in order to improve is right there, easily accessible for you. So what tools are available in your local development environment? Some tools I found super handy, again, are unit tests. You can run these in the background. They're just running all the time. Every code change you make and save, you see, awesome. Are the tests green? Are they red? And that gives you really fast feedback of being able to fix broken tests and being able to direct your energy into a productive direction. A thing about tests that most people misunderstand is that they are a tool for directing your energy. They're a tool for directing your attention and setting an intention for what you're doing. This is the concept behind test-driven development. You write a test saying, I want this to happen. You run the test and it doesn't work. Of course, you didn't write the code yet. But then you write the code and you verify, yes, what I wanted to happen did actually happen. It's like putting an intention out there saying, I want this button to be red. You check that with the test and you're like, well, that's not the case. But now you have a direction that when you go and work on the code, you have a clear measure of success. You can clearly see when you've accomplished your goal. So it becomes a goal setting and goal achievement loop. So you're aiming to loop your success. So set a goal, that's your test. It's failing. Code it, to succeed. And write a test, make it succeed. Write a test, make it pass. And loop it, loop it, loop it. That's your feedback loop. You set an intention and then you get feedback on it. You set a goal and you make it succeed, and then you find out what's the next thing. What's the next thing that's going to make this code achieve the user story aims? Amazing. So that's just tests. Another way to incorporate tests and incorporate faster feedback into your process is pair programming, or collaborating, working together, talking with someone else about your problem, about your ticket, or perhaps their ticket, sharing information, talking to other human beings, talking to your product manager, talking with your designer, talking with other engineers. Great. As long as it's goal-oriented and you all are all solving a problem together, that can be fantastically useful. Why? So let's focus in on the engineering pair programming side of it. You can have feedback, let's say, from your coworkers at the pull request level, or if you're both working on it at the same time, then you both load in the ticket context into your heads and work together on it. You get feedback in the moment. Those things that you're good at, that knowledge that you have, perhaps you're good at the domain and the collaborator, the coworker is really great at the technology that you're using. Well, you can provide the domain knowledge, and anytime you have an issue, you're forgetting a specific part of the technology that you're using, your coworker can help you. And when you switch off and your coworker has a question about the domain, and like they're coding excellent tests and other stuff and code and systems, but they have a question about the domain, you can provide that knowledge. So it's using two heads instead of one. You get that back and forth feedback. Incidentally, with some styles of pairing, you may end up finding that you just have an open dialogue, and it's a lot more flowing and in the moment than just being focused in, zeroed in on whatever the problem that you're working on is. There's pluses and downsides, and there's specific styles available that will optimize for both of your times. But consider, you both are getting context, you both are loading in that context in your head. And that effort, that time that was spent pair programming, that's time that you don't have to waste in the pull request review stage. So now you already have had another pair of eyes on your code, and you both are reasonably confident that it will work. So that actually optimizes energy and context switching, not just for you, but for your coworker as well and your broader team. That gives you the opportunity to focus in better on that specific user story that you're working on, and not feel the mental fatigue of having to switch tasks and load in the new context into your head about that pull request that your coworker is doing. If you don't have a pairing practice in place, by all means, load in the new context and review your team's work early, because that closes their feedback loop. That helps them learn faster, and that helps the product to iterate faster and get more value out to the customer. What about other tools? Of course, there's automations. There's the same automations that are in your pull request environment, like checking your formatting and your linting. You can set onSave hooks into your Visual Studio Code or into your other IDE. And that will automatically format your code for you. That will automatically show you red lines where there's issues. Great. Now, if there's issues, how do you close that feedback loop? Recently, I was looking at some TypeScript issues, and I was getting really confused about these types because I'm using a library and some issues were coming up there where the typing wasn't correct. Maybe one type was more generic than another and I couldn't assign it. And I got a stack trace. And it's, TypeScript. Perhaps the stack trace wasn't as helpful as it could have been. So how do we close that feedback loop? Conventionally, we type that into Google. Hey Google, what's this look like? Like, how do I solve this problem? And you'd get a Stack Overflow. Okay, but what if that doesn't help? In fact, the tool that I found really interesting to use was ChatGPT. And this is the large language model, and you can type in prompts and it will return kind of the aggregation of what's on the internet that seems like it would answer your question. So I put in my error and my code and asked it to fix it. Well, not only did it give me a suggestion of the code that I could use, it was wrong, but what was more handy was it explained the problem. It explained in human readable language what that problem, what that error message was telling me. Because otherwise I would have had to really dig deep and figure out, browse through documentation in order to find out, how do I fix that? Instead, this AI model would give me an answer that is reasonably close. That prompted me to think, oh, okay, let me try this code that it gave me. Perhaps it didn't work. Likely it didn't work. But with the explanation, I was able to close the feedback loop and address the issue that I pointed out. It gave me a new direction to move in order to fix that problem. So feedback loop closed. I had a goal, which I set out into ChatGPT, fix this issue, and I got an output. And then my goal was fix the type error in my code. And I got feedback on it with the linter consistently as I tried to modify the thing. And that was split seconds. So as I was thinking and typing, I would get feedback in very, very quick succession. This seems rather obvious, but when we look at the scale of learning, we want to learn on every single scale within our application, from the smallest scale to the largest scale. By the way, if you're looking for another AI tool, there is also Github CoPilot. There is a very handy way to use it, for example, for writing tests. It'll test common scenarios that may look like boilerplate code. And that's all right, but that allows you a depth of testing that you don't have to think quite as much about. You don't have to think about the details quite as much as broadening out and saying, what kinds of things do I want to test here? What kinds of things do I want to write here? You can write prompts for the tests, and that can help. You can also use CoPilot for refactoring, and that's very handy. Like that, again, closes your feedback loop around you're intending to do something. You have a goal, and you are able to use this tool to accelerate your impact. You're able to accelerate the progress that you're making by using this essentially autocomplete tool. CoPilot, a glorified autocomplete, great autocomplete, but you get to type out your code faster and test out your intention, whether what you're intending to write, whether that's going to work. You get to learn about any new things that AI suggests to you by, let's say you see a function that it's suggesting and you don't know what that does. So you Google it, or you ask ChatGPT to explain it for you. Cool, you learn about it and you can make a decision using your own human brain of whether that is or is not applicable for this situation. Amazing. That's another piece of learning that you made. So why do I harp on all this learning at every single stage of the process? At the broadest level, when we're working on a product, we're trying to discover what it is that a user wants, what kind of goal they're trying to achieve, and whether the means that we're suggesting of achieving that goal for them is something that's relevant for them. If that's something that, in actuality, a process that they would find useful. So why do I harp on learning? We're looking to find out what the user wants and whether we can help them achieve their goal. So if we're aiming to help them achieve their goal, we need to find out what goal they have. There's some research into that that's qualitative, such as talking with the user, talking with your potential customer. And then there's also observing what it is that they do via performance monitoring, via maybe user sessions, guided user sessions using the application. Another really long feedback cycle, but a high signal one. So we want to start looking at how can we help the user to meet their goals, whatever those goals may be. In order to help them achieve their goals, we have to learn what those goals are. We have to learn about the technology that's building the website, that addresses the needs, that help the user solve their problems. Okay, so every single level of learning is important. As an engineer, it's not just that we have to understand the technology. We also have to have some inferences around what the user is looking for, because that understanding of what it is that the user is looking for, what goals are they aiming to achieve, and why are they even there in the first place, can help guide minute technical decisions that alone might be, up in the air. Maybe they're not listed in the user story, but with an understanding, with a amount of context in your head about what it is that the user is looking for, how they use the app, what their existing mental models are, you can actually start to insert these high quality data points, like high quality decisions that will help the user reach their goal faster or more effectively. Are they concerned with speed, or they want to be highly confident about the result that came up, about the process that they're going through? Or maybe it's that it feels super smooth and responsive. You want to know about your user profile and have an intuitive understanding of what it is that your user is doing and what they want. And you learn that through these incremental feedback loops. So remember, it's not just about your technology. It's not just about the software stack that you're building. It's also, in the end, a way to serve the customer, a way to serve the user, to help them reach their goals. And you as an engineer are learning about them every day. Your role as an engineer is consistent learning over time so that you compound your understanding. You're more effective in your role with every single decision you make. As an engineer, every decision you make is another brick of automation that crystallizes knowledge from the organization into an end product. You may have an insight, or the product person may have an insight, or someone on the team may have an insight about the customer, and it shows up as a specific feature. You develop that, get it all the way into production, and you find out that that is something that the user wanted. That does help the user. That does lead them along the process that helps them achieve their goals. Well, now that piece of code is a crystallized piece of knowledge of your organization that is another component to understanding your user. And you stack enough of these bricks, one on top of the other, and you build a very solid structure. You build a very solid building that meets the customer's goals, that helps the customer along their path towards their goals. And that is very, very powerful. That reduces all the context that you need to have in your head about the customer at any given time, and you get to offload that into this knowledge base, your code base, your organizational document sharing, and perhaps drive. Great. This crystallization of knowledge inside of code helps your team provide an excellent experience to your customer. This helps to meet the expectations of your customer and perhaps exceed them by compounding your understanding of everything from the core components of your technology, of your working environment, to the systems that you're working with, to the needs of the customer and their persona. And all of that compounds until you're delivering a massive amount of value to your user. And that is why feedback loops are important. They help you learn faster and at every level. I'm hoping that this was useful for you, and let me know if you have any questions, comments, concerns, and comment on the video, subscribe to the channel, and look forward to seeing you again. Peace out.